All right, today's lesson is on section 2.7, division of real numbers. And the same rules apply with division as they do with multiplication. So positive divided by a positive is a negative divided by a negative is a positive, etc. A reminder to you now that we're dealing with real numbers is that when you divide fractions, you have to multiply by the reciprocal. So keep that in mind as we're working through these. So now we're taking a lot of different things that you've learned in the past and combining them into one, positives and negatives and fractions and so on. So we have positive 15 divided by negative 5. Positive divided by a negative is a negative. We take 15 divided by 5 and we get 3. So our answer is negative 3. Example number 2 has a fraction. We have negative 45 divided by 5/6. We keep the first number. We multiply by the reciprocal, so I multiply by 6/5. And then you can simplify ahead of time, which I like to do, so I'm working with smaller numbers. So 5 and 45 can be simplified to 9 and 1. So then I take negative 9 times 6, which is negative 54, and my denominator is 1, so my answer is just negative 54. For example number 3, 2 1/3 divided by 2/3, I have to first change 2 1/3 into an improper fraction before I can multiply or divide. So I have 7/3 divided by 2/3. Again, with dividing of fractions, I have to multiply by the reciprocal. So I have 7/3 times 3/2. I cross-simplified my 3's, so then I multiply across and I get 7/2. Both are positive, so I have a positive answer. Now, we are talking about division and variables, and so if we evaluate this expression, s minus 3t divided by 2s, I'm going to plug in negative 3 for s and negative 1 for t. So then when I substitute those in, I follow my order of operations. So I take 3 times negative 1. So I'm left with negative 3 minus negative 3. And then 2 times negative 3 is negative 6. And then I take negative 3 plus positive 3, which is 0. And then I take 0 divided by negative 6. Well, 0 divided by any number equals 0. However, if you divide a number by 0, you get something that's undefined. So if the bottom of the fraction is 0, I don't have a solution. It's undefined. So if we want to define the domain of a function, remember, domain is all the inputs, what I can plug into the function. The denominator of the fraction cannot be 0. It can't happen because it would be undefined in that situation. And here's how I think of this. If you have 0 cupcakes that you're dividing between 5 people, how many does each person get? Well, 0 divided by 5 is 0. Every person gets 0 cupcakes. However, if you have 5 cupcakes and you're dividing them by 0 people, you can't do that because you don't even know that the cupcakes exist because nobody is there to verify it. So a number divided by 0 is undefined. So when we look at this, like the example 3 over x minus 2, x minus 2 cannot equal 0. So I need to figure out what possibilities x could be, but it cannot be a number that will give me a 0 in the denominator. So if I then take x minus 2 equals 0 and I solve it, I get x equals 2. That means the domain is all real numbers except positive 2. So I can put any number into that function and it will be true as long as it's not negative 2, because negative 2 would make it undefined. So what I'd like you to do with these 3 examples on the back of your notes is to find the domain of those functions. Find out what value the variable would have to be, in this case x, in order for that equation or expression to be undefined. So you're going to set the denominator of each of those fractions equal to 0. Give those 3 problems a try. Make sure your notes are complete for tomorrow, and have a good night.